already, welcome back, boys and girls. It's your man, Math Man Shane, coming to you live from Summit Academy. In this video, working on some lesson number 5 for unit number 3, and we're talking about some inequalities now. So this might be a little bit of a review, but I want to make sure everybody's on the same page. So for our warm-up, it says to move the 4 points to represent 4 different numbers that are more than 5. So notice how they use this terminology, more than. So we're going to say, I can drag these points over to the right, and it has to be a number more than 5. So something like 5.43. We could say something like 6.52. Let's do 8.9, and let's go the whole way across 10.03. Sounds good. And then it says to write the inequality represented on the number line in the graph below. And so we have to use some of these key words for this. So we could say, I could write something like this. I could say x greater than 5. And so we can have something like that. And you want to remember some of these symbols that we have. So what I can do is I can just kind of draw some notes on the side here, but I'm going to have a little bit of a blank page or something like that you can draw on, but we can say, okay, we're going to say, again, this symbol, we'll add alligator eating to the right, is going to be the greater than symbol. And then we could say going the other way is going to be the less than symbol. And what we have to make sure is when we're looking at the graph, it means it's going to be an open circle. And that just means that when we graph it out, it has an open circle, and that just means it does not include value in solution set. And what I mean by that is just all the possible answers that we could have. Again, if we were to look at that graph again, I would not include 5 because it's strictly greater than. However, if we look at the other options, we could say, we have greater than or equal to, so it's greater than or equal to. And you could say the other option is going to be less than or equal to. And that means it's going to be a closed circle or filled in circle, you can call it. And that just means it does include value in solution set. And we'll show what that looks like, but I wanted to give you those just general definitions and seeing how these words work when I am being able to explain these out. So let me highlight this again. Okay, so now let's go to the next part. Again, what we're going to be able to do is we're going to be able to solve inequalities on a number line. We're going to be using that language of compare and contrast. So it says to now move the 4 points to represent the 4 numbers x such that x plus 1 is less than or equal to 5. And we have to be able to solve for that first. And so what I can do is, let me go back to my screen here. I'm going to clear this out. So I'm going to say it has the inequality x plus 1 is less than or equal to 5. And what we're going to do is we're going to use the same steps, so use inverse operations. And what that means is we're going to have the same kind of idea as what we had from before. So for example, if this was an equation, we'd solve for x. So I'd say, okay, I have to subtract 1 from both sides. And I would say, okay, I have x is less than or equal to 4. And so that's going to be my answer for this one. So let me hide that. And then let's go back here. So it says something like this. I'm going to say, so let's say x, and then I can click the little keypad button, and I click the less than or equal to. I'm going to have less than or equal to 4. And what I have to do now is I have to move these points over here. So I'm going to say, okay, I have to have 4 points that such that they're less than 4 or equal to 4. So I can actually move it on to 4 if I'm able to do that. If not, no big deal, but I can just move them to the left. I can say 0 is a solution. I can say -5 is a solution. Any of those choices would be okay. And so what we can say is, if we scroll down a little bit, we can talk about what we're saying. So we're saying using the inverse operations, we get x by itself. So we're always trying to do that. Again, it's just like when we're solving for our equations. What do we have, or what do we need? We'll be able to do that. So let me hit the next one. So same kind of idea. So now we're going to say, okay, if our equation is, or our inequality, I should say, is 4x greater than 8 or equal to 8. So let me write that one out. So let me clear this one out. So it has 4x greater than or equal to 8. And still the same idea, use those inverse operations. So I'm going to divide 4 to both sides because then you get x by itself. I'm going to say x greater than or equal to 2. So there's my inequality for this one. So let me switch over back to this one now. So I'm going to say anything less than or equal to 2. So far, these first three are okay because they're 9, -4.6, and 0. So that works, but now I need to move it down to be less than 2. So I'm going to say x, I'm going to say the keypad, and greater than or equal to 2. So I can say any value that is less than, or sorry, actually that's why I said greater than, so let me actually fix that. So that's why I type it out, because I want to make sure I'm doing it right. So I actually go to the right, so I need to have values greater than 2. So there's some options there. So notice how it's shaded to the right because it's pointing that to the right. So I'm going to say, what do I have down here? I'm going to say any value that is greater than or equal to 2 is in the solution set. So again, be able to go from the equations or the inequalities to the graph to be able to say a little sentence about the graph. All right, same idea. Now this one's going to be a little bit different because we actually have to do one extra step here. So it has -3 times x is greater than 12. And so let's solve what that's going to look like. So let me hide this real quick. So I'm going to say, all right, I have -3 greater than 12. So let's say -3 x greater than 12. And so same step, I need to divide by that coefficient. However, when I divide or multiply by a negative number, so when you divide or multiply both sides by a negative number, try that again, change the direction of the inequality symbol. So all we're saying is when I divide or multiply both sides by a negative number, this inequality has to be flipped. So right away I'm going to write that out. So I'm going to say it's going to be less than. So I have now x less than, I'm going to say -4. And so you have to make sure you're careful on that because a lot of people will see a negative answer and they'll say I have to flip it, but it's only when you multiply or divide by both sides. So make sure you're careful on that setup. So we're going to say, let me hide that again. So let's say for this one, I'm going to say x less than -4, and I'll have to move my graph to be that. So I have to have values strictly less than -4. So I have to have things that are below -4, and 0 is not a solution, so I know it can't be that. So I can put some numbers down and below there. Again, I can have it on, let me actually put one on -5, so that way it's a little bit more spread out. Okay, and so we're going to say any, so let's say what we just wrote, we said when we multiply or divide both sides of an inequality, multiply both sides by, multiply or divide both sides of an inequality by a negative number, we must change the direction of the inequality symbol. So again, if it was a less than or equal to, we would have to keep it the equal to part, but we flip the direction of which way it's going. So make sure, again, you're signed in the top left, hit that red button, so that way it saves your work. All right, moving on, this is what happened. So looking at some of these inequalities, so it says all numbers more than 5, so that's the correct inequality, so we're good on that one. On next, number 2, it says correct inequality is x less than or equal to 4, so we're good on that. Correct inequality for number 3 was greater than or equal to 2, so we're good on that. And the last one was x less than -4. So what is different about the last inequality than the first 3, and why is that? So exactly what we're saying. We're going to say we divided both sides by a negative number, so that meant that we changed the inequality symbol to be less than symbol, say it. And we can just kind of say, when we say why is that, we can say just the same thing as before. So if you want to, you can go back and copy and paste that in, because it's going to be the same definition that we just had. So let me hit enter, and we're going to say when we multiply or divide both sides of an inequality by a negative number, we must change the direction of the inequality symbol. So exact same definition that we had before, just want to make sure that we had it in there. Okay. Moving on to the next one, it says move the 4 points to represent the 4 numbers such that 8 less than or equal to -2x plus 5. So let's try to solve this first. So let me pull this back up. And let me clean it out. So it's going to be 8. What was it? There it is. Okay. We're going to say 8 less than or equal to -2x plus 5. -2x plus 5. Okay. So here's our inequality. We have a couple steps to it because it's similar to a 2-step equation. So you have to make sure we just take it one step at a time. So first step, still doing inverse operations. I'm going to subtract 5 from both sides. We did not multiply or divide by negative, so the inequality symbol stays the same. So I have less than or equal to. So on the left side, 8 minus 5 is 3. And on the right side, the 5's cancel out and the -2x comes down. Now this is where we have to flip that sign. So we're going to say divide both sides by -2. Since we divided both sides by a negative number, we have to flip our sign. So we say -1.5 is greater than or equal to x. But we must have variable on left side. So you have to make sure you're careful in this, so that way you can graph it out. So what that means is I'm going to say x less than or equal to -1.5. That's going to be our answer, because that way it's easier to graph out, because let's say the inequality symbol shows direction. Meaning, if you look at the inequality symbol, notice how it's kind of like an arrowhead. It's pointing to the left there. So I'm going to say any value that is less than or equal to 1.5, meaning if we were to graph this out, I would say, okay, negative 1.5, I would have a closed circle on 1.5, and I would shade everything to the left. So let's graph that out and see what it looks like. So I'm going to say, okay, x less than or equal to negative 1.5. And let's move these values to be below that. 0 is not a solution, so we have to move that down. Positive 5 is not a solution, so we have to move that down. So I can put it I can actually put it on negative 1.5 since it has that filled in line. It'd be a closed circle on 1.5. All right, moving on. We have this one, and so it says, look back at the last few examples that you got correct. What determines when the solution graph has an open circle or closed circle as a boundary point? So what it's talking about is looking at, these symbols here. It tells us this. So we're saying when it has a filled in line, then it has a filled in circle. And what that means is on the boundary point, so on the boundary point, meaning, for that last example, it was negative 1.5, we would include that value in the solution set. And I write the same kind of sentence. So when it has a open symbol, then it has an open circle. That means on the boundary point, we would not include that value in the solution set. So same kind of sentence for both of those. You just want to make sure you're changing it since we have two different types of inequality symbols, so you have to be careful on that and make sure you're just hitting that share with class button. Moving on to the next one, let's compare and contrast. So it says here are two number line diagrams, or graphs you could say. How are they similar? How are they different? So you could say sentence starter would be these two graphs are similar because they both have a boundary point at -1. And you could say these two graphs are different because the top one does not include -1 in the solution set, but the bottom one does. And the reason why that is because if you look at this graph, notice how it's an open circle on -1, however it's a closed circle on -1 on the bottom one. So that's some similarities and differences, but you need to make sure those are separate. All right, moving on. For this one, it says open versus closed, so just like we're talking about. It says the open dot above means that -1 isn't included. However, the closed dot below means that it is. So now what I want you to do is I want you to take your time, match each expression with its number line in the graph. So I'll give you about a couple minutes to try this out so that way you can try it on your own. All right, so if I'm looking at this one, it's real simple. The way I approach it is to kind of separate the graphs out so that way I can kind of see what I'm working with, and then that way I can find and choose what I need. So starting on this one, if I'm looking at this one, I'm going to say, hey, it has a boundary point on +1, and it's shaded to the left with a closed circle. So I need to have one that has +1 and has a closed or filled in line, shaded to the left. So notice how that arrowhead is, pointing to that left side. So I'm going to pair these two together. And for this next one, I'm going to say, okay, +1, but it's shaded to the right with an open circle. So I'm going to say it's going to be this one here, x greater than 1. For this one, I have -2 closed circle shaded to the right. So I have -2 closed circle shaded to the right. This one's going to be +1 shaded to the left. Open circle. I have -2 less than or equal to that one. And then for this one, I have x greater than -2. So make sure you can match those up for yourself. Again, real simple. All right, for this one, I'll do with you, and then the next one you'll have to do on your own. All right, so for this one, it says sketch the solutions on the number line that make the inequality true. So we have to first solve our inequality. So I'm going to say something like this. I have 5x minus 4 less than or equal to 11. So what I have to do some inverse operations. I'm going to add 4 to both sides. So I have, it's going to be 5x less than or equal to 15. Divide both sides by that coefficient, so divide both sides by 5. And I'm going to say x less than or equal to 3. So that's going to be my solution set. So now what I do, I'll use green to kind of, or let's use purple, a little bit darker. I'm going to find where my boundary point is. So I find on +3, I'm going to say I have a closed circle on +3. I'm going to shade to the left because it's all values less than or equal to +3. So let's type that in. So let's say x, x less than or equal to 3. And then you can type it in. So use inverse operations to get x by itself. And we said closed circle because it has a filled in line. And we shade, let's say shaded to the left. So try that next one out. Again, use this as an example. Be able to set up your two things. Again, make sure that you're flipping that direction because of the negative symbol. Try it out. Make sure you can check with me. Otherwise, be sure to ask questions as they come up. And as always, super slam that subscribe button.